Good morning, class. This is Mr. Arnold. Today we're going to talk about Gay-Lussac's law. This should not take very long. Gay-Lussac's law is the relationship between pressure and temperature, and most of you guys realize this. If you put like an aerosol can in the fire, it will explode. Why? Temperature goes up, pressure goes up. If you take an aerosol can like a spray paint can and you spray it, your finger will get really, really cold. Why? Pressure goes down, temperature goes down. Hey, let's just get right to it. Here's our equation. Our equation for Gay-Lussac's law is P1 over T1 equals P2 over T2. Maybelline Cousteau backup oxygen tank reads 900 mmHgs while on her boat, where the temperature is 27 degrees. Sorry about that. It looks like I have a little bit of I need a superscript on that degree sign. It's just a circle, or no. When she dives down to the bottom of an unexplored methane lake on a recently discovered moon of Neptune, the temperature will drop down to negative 183 degrees Celsius. What will be the pressure in her backup tank at that temperature? Ooh, a sci-fi problem. Okay, let's see what we got here. Pressure 1, 900 mmHgs. Temperature 1, 27 degrees Celsius. Pressure 2, we're trying to find. And then temperature 2, a negative 183 degrees Celsius. Okay, we have one thing to think about here. Well, two things really. Consistency of labels. We have to make sure our labels match. If this were pressures, right, that we had two pressures, we had to make sure they're the same label. We'd have to convert them if they weren't. In this case, we have two temperatures, and temperature always has to be in kelvins. So we have to convert both temperatures, always convert to K. So plus 273 equals, is that 300? And then plus 273. There's a negative number there too, so make sure that you realize that. So you have 273 minus 183, and that is 90. All right, there's our givens equation. All right, when we're setting this thing up, let's go right here for a second. We have our equation is P1 over T1 equals P2 over T2. Oops. Pause. Remember when we're solving for temperature. Oh, we're not. Okay. Never mind. Duh. It's early. Okay. We're solving for P2, right? So solving for P2, we have to get P2 by itself. So let's lasso that T2. And let's move it up to the top. See, we're just cross multiplying. You can throw a 1 down here if you want. All right? Now we just have to sub in our numbers in the correct spots. So we have T2 times P1. So 90 times 900 divided by T1, which is 300. Oh my gosh, we could almost do this one in our head. I'm going to say it's like 270. Let's check it out, see if I'm right. 90 divided by 300 times 900. 270. And that is mmHgs. Remember, the labels are consistent. It has to be in Kelvin. You should have no problem with these problems. They work out just almost exactly like Charles' laws do. All right, let's go. We have another example. That was the only Gay-Lussac law that we have today. So the problems are on the, check out the problems. Remember, if you're solving for temperature, flip the whole thing over. It shouldn't be any problem. I'm not going to take up any more time with this today. I think I have 7 problems on that thing today. Should be an easy day. All right, thank you very much.